We don't make things, we don't make products, we don't make software, we're just responsible for the engineering specifications that define how Bluetooth works. The core spec is 3,000 pages, be afraid, and there are lots of other specs that define how you use Bluetooth. So we're responsible for that stuff, but we don't make anything. We just do our best to make sure that all the manufacturers do things the same way. That's how devices are made to work together. So I'm here to talk about something called Web Bluetooth, which is an API for web developers, lets you do some Bluetooth stuff from a browser. Interesting fact about Bluetooth before we get into that though, did you know 10 million Bluetooth devices ship every single day? In the first year of existence, it's about 20 years old now, 800,000 shipped in the entire year. Now it's 10 million every day, so it's absolutely everywhere. Totally ubiquitous wireless communications technology, therefore it's worth knowing about in the age of the Internet of Things, amongst other things. So I think most people tend to associate Bluetooth with consumer products, kind of consumer electronics, that kind of thing. Understandable, because it's been really successful in that kind of area. But quietly, it's been making its way into the world of the enterprise system. The reason for this, probably many reasons, but the range is enormously better than it used to be. Again, you probably won't believe me, but it's over 1 kilometer in the latest release. Over 1 kilometer, can you believe that? Twice as fast. Look on YouTube, Mr. Cynic in the audience, I like cynics. Look on YouTube, you'll see some of the kind of Bluetooth chip manufacturers demonstrating the range of the latest version, which is Bluetooth 5. So pretty phenomenal. It's twice as fast as it used to be as well, 2 megabits per second, which is slow for all sorts of applications, but very fast for the kind of things that this is meant for. And we have something called mesh networking now as well, which is new last year, and this is about creating networks of tens of thousands of Bluetooth devices. And it's designed for things like smart buildings, where every light, every switch, every air conditioning unit, every heating unit, the blinds in every room and so on, they're all nodes in a Bluetooth mesh network, and you can monitor and control everything wirelessly across a very, very large area actually. So these are all kind of IoT style things. They're absolutely enterprise applications. And I did spend some time working in the world of enterprise systems, so I know, and I'm sure you know, that nobody writes native applications for the 15,000 Windows users across the company, plus the 2,000 that use Macs in the various marketing departments across the world, let's say, and the collection of hardcore Linux users in the IT department. Nobody does that anymore. Never mind the mobile workforce with iOS and Android doing battle there. So it's all about the web. The browser is the platform. That's what enterprise systems thinking is all about. And in my mind, there's some logic that kind of we can follow through here. You can see if it's logical or not, but I think it is. Bluetooth is regarded by most kind of industry observers, analysts, people like that, as being one of the key enabling technologies for the Internet of Things. IoT architectures tend to be multi-tiered, and around the edge of these multi-tiered systems, you get small devices, microcontrollers, sensors, things like that. That's where Bluetooth Low Energy specifically lives. And if you look at those applications, those IoT applications, they're all enterprise applications. There's some B2C stuff, business to consumer, but that's just enterprise by another name. So, given what we know about enterprise systems thinking, that the browser is the platform, and we need Bluetooth for all these enterprise-style IoT applications, kind of stands to reason we've got to have Bluetooth APIs in the browser. And not just Bluetooth APIs, what we need are standard Bluetooth APIs. Because Web Bluetooth is not yet an accepted W3C standard, but that's where it needs to be. And by the way, QED, that's like Latin for proof. So you can't argue with me, that's my logic, my logical argument. So here's the current status. Google have really led the way. So Web Bluetooth is pretty fully functional in all the platforms that Chrome is available for, except for iOS, but it's in all of the others. Samsung Internet Browser also supports Web Bluetooth. So if you've got a Samsung phone, they have their own browser, and it supports Web Bluetooth as well as of, I don't know, 6 months ago or something like that. But the ones at the end, they're in red, they don't yet, and obviously that's quite important. if this is to become a fully fledged W3 standard. However, as you may already know, I think there was an official announcement today and a kind of leak a month ago or something. The big news, you know about this, is that Microsoft look like they might be waving goodbye to Edge and we're going to get something new which is really Chrome underneath. It's like Credge or, I don't know, I'm sure they're working hard on a name. You're laughing, I have suggested that to the product manager at Microsoft and he didn't say no. So, so who knows, you heard it here first. So, but that would be big news, right? So that's another big browser company adopting Web Bluetooth in its browser. So we'll see, we need this through the W3C though for this to become a really serious proposition. So what can we do with it? I like to simplify things, and in my simple mind, I think there are really only two use cases for the IoT, Internet of Things. They boil down to these two things. It's either about monitoring devices, systems, whole environments. That tends to involve sensors. It's about finding out what state things are in, doing something with that information. Or it's about controlling devices, systems, environments, machine-to-machine type stuff. And often they get combined. So monitoring is giving feedback information, giving information that gets fed into the kind of control subsystem. But this is really what it all boils down to. So, can we do these things today in Web Bluetooth? I hear you ask. Well, I'm going to try and show you. I've gone all nervous now. I've lost my voice. I can't speak. So let's give this a try. I've got a few things to show you that have travelled in the hold of a plane, so who knows what state they're actually in. But bear with me a second. We'll start here. So who's heard of a BBC microbit? Microbits, you heard of that? Oh, not many people. So this is a BBC microbit. It's a microcontroller, in other words, a computer on a chip. It's got sensors inside it, it's got a display and some buttons, and it's got Bluetooth. And it's programmable. It was made in the UK by a team kind of sponsored by, let's say, the BBC. They brought some industry experts together. I was one of them, as it happens. And they gave $1 million to British schools for kids to learn to code. There are now millions, plural, across the world. They're in something like 40-something countries. There's one country where every child has one of these. Don't have time to tell this story. I'm going off script, but they're all over the place now. So what you're looking at is a website called BittyWeb, Bitty for microbit, used in schools, and I'm going to just plug this in, turn that around the right way so I can do that, and try and show you something. So first of all, monitoring. Often about sensors, and as I said, we have sensors. Oh, hang on. Oh, I knew this would happen. I'm going to have to unplug because I don't want you to see my password. Call me paranoid. I know you're all nice people and everything. Here's where I can't log back in again because I've forgotten my password or something. Now we're all right. Thanks. Okay, so what we have here is a collection of web applications for use with the BBC microbit. He said filling time. Did it work? It worked. Okay, cool. So let me show you the first one. What I want you to watch carefully here is the flow, because it's very standard. You'll do this kind of thing yourself if you decide to do so. So my microbit right now, sat on the table there, is actually broadcasting some information. It's called advertising. It's a kind of attention-seeking behavior. It's like, hello, I'm here, please discover me. When I hit the scan button, oh, and by the way, I'm not really a web developer, can you tell? I use tables for layout. I blurt out confessions at inopportune moments. So, first thing you do is you have to discover that device. So hitting the scan button called the Web Bluetooth API, it's scanned for these advertising packets that are flying through the air every 100 milliseconds, found it, listed it, and I'm going to say, yeah, that's mine. And in doing so, I caused a connection to be made from my browser and my code to this device on the table right now. I'm going to hit this button, and it will send a Bluetooth message by calling a Web Bluetooth API to the connected device to tell it, please start sending me accelerometer data, because it has an accelerometer in it. So right now, 3 lines for X, Y, and Z. It's wobbling around a bit because the stage is wobbling. If I do that, you can see that. If I pick it up, though, oh, look. So live sensor data being acquired from this device. all sorts of applications for this kind of thing. In schools, I've seen them teaching Newton's laws of motion using this application and stuff to do with electronics, all sorts of things. So live collection of data from sensors to a web application, which I think is pretty neat. And I hope you do too. So that's one of the monitoring use cases. I've got another one, I've got two for control. I'll see if this works. I haven't tested this. That was silly, wasn't it? So scan again. Live demo with no testing. I'm going to regret this. You'll edit this, right? This isn't live, is it? Oh, it's live. Oh, no. Oh, that didn't work. Let's try that again. Come on. Yeah, this might be a bad idea. Okay, let's not go off script again, Martin, and try control instead. So, yeah, I don't know why that didn't work. That should have worked. Under here, oh look. So this thing it's a kit which I made. It's a kind of vehicle. It has another microbit plugged into it, so it's electrically connected to the motors inside this thing, a motor driving each wheel. And I can send Bluetooth messages, commands to the code running on the microbit to say, make that motor go faster, reverse this motor, stop this motor, that kind of thing. And that should let me control it. Now, I did notice, when I tried this earlier on, bit of an issue. The firmware on that is out of date, and there will be an error on screen. But don't worry, do not be alarmed. It's all going to be all right, maybe. Have I fallen off the Wi-Fi here or something? It's very slow, though. Might be tricky to complete. Yeah, we're off the Wi-Fi. Oh, no. Well, that's OK, because I'm just going to let you imagine how great that would have been. It's OK. I'll move on to my next demo, which is running locally, so we'll be OK with that one. We'll maybe come back to that one, otherwise we're going to be like massively overrun. So you can control stuff, take my word for it, it's brilliant. I can pull wheelies for this, actually. So the other thing I brought with me is this, and I've not actually done this for a web audience before. So this is a whole presentation all on its own that I don't have time to do today. Bluetooth, you're used to being about two devices connecting and sort of talking to each other. That's usually what you're doing with Bluetooth. It can broadcast data as well, so that's like a one-to-many communication. But usually it's kind of one-to-one. It's your Fitbit, your activity tracker, talking to your phone, something like that. So last year we released the specification for something new called Bluetooth Mesh. This is a networking technology, and as it says up there, it lets you basically form a network of up to 32,767 Bluetooth devices exactly. It's a new networking stack that uses Bluetooth Low Energy for wireless communication. And it's for the things that are on the screen there. It's for smart buildings, where every single light is a node in your network, every switch, every air conditioning unit, the stuff I said earlier on, that's what it's for. Lets buildings become self-optimizing, working with sensors, energy efficient, very intelligent, all sorts of stuff like that. It's message-oriented, so messages hop across the network from device to device to device, so you're not constrained by the direct radio range, and the range is hundreds of meters for Bluetooth Low Energy anyway. So you can do 127 hops, span a huge area with mesh networking. Now, normally, this is not something which is necessarily of interest to the likes of you. Web developers, that is. I didn't mean anything bad by that. I don't know anything about you, but I'm sure you're all lovely people. So normally this is about machine-to-machine, kind of microcontroller-to-microcontroller scenarios. You hit a button on the wall, all the lights in a room come on. Here's a microcontroller. There we've got 64 microcontrollers, and nothing's happening. Oh, I hate myself. What's going on now? Is this even powered? Hang on. Oh, this is fun. Let's move on. Yeah, I think I'm sharing a battery pack here, which also is a bit of a precarious thing to do. Let's try that again. Yeah, okay, that was a power problem to the microcontroller. So normally it's just pressing buttons and stuff like, and sensors talking to other machines. That's the scenario. And we have a kind of group-based addressing scheme. So things tend to be in collections or groups. So what happened there was my microcontroller sent a message that meant bottom right-hand group, please switch on. And then I sent the same message with a value of 0, meaning please switch off. Lots of message types defined in the spec. On, off, change level are the simplest possible use cases. There's some really sophisticated stuff in there as well. But what's the relevance to you? Well, 10 million devices shipping every day. Obviously, we wanted to make sure that for relevant types of existing products, they had access to the mesh network. Smartphones, browsers, web Bluetooth and so on, they don't have a Bluetooth mesh stack. It's a new protocol stack. So a mesh network can include something called a proxy node, and a proxy node understands the messages that web Bluetooth will create, or a smartphone app. That's kind of, let's just call that standard Bluetooth low energy, and it lets you inject mesh messages into your mesh network. So now it's not just machine-to-machine type stuff. We can create graphical user interfaces for monitoring and controlling large networks in things like smart buildings, smart industry type applications, and so on. So those were my easy demos. Now I'm going to do the really scary hard demo. And this thing traveled in the hold of the plane and bounced off the conveyor belt. So, who knows what's going to happen here. So what I've got, so let me introduce the demo first of all. Again, 64 microcontrollers here. They're each kind of individually numbered. If I press a button, they light up and display their number. So 64 at the bottom right there. I've got this microcontroller here, a bit more memory on this one. That's my proxy node. And possibly somewhere running on my, there it is, laptop. I've got a local web server, so we don't need the Wi-Fi to work this time. And I've got this fabulously crafted web page, thank you very much, which of course reflects the savior of the Lego industry, which is my mesh demo. Now,
is this all tables?
I'm sorry?
Is this all tables for layout?
I'm not going to tell you. No, it's all beautiful CSS, beautifully crafted. How dare you? What sort of dinosaur do I look like? So, first thing I need to do is use Bluetooth, Web Bluetooth API to, hang on, let me just, I don't like the look of this at all actually. Hopefully that's the right device. What I've done is I've discovered my proxy node, which behaves like a normal Bluetooth device, but also it's part of my mesh network. And with a bit of, what I can do is I can click around. You see at the top right there, it says DST. That's destination address. So we have an addressing scheme, and FFFF is a special address, which means all nodes in the network, which we recommend nobody ever uses. So I'm going to use that. If I click around, I can change that to other addresses that are for individual groups of devices. Let's just hit a button. And oh, look, it worked. I'm massively relieved. Obviously, I have full confidence in the technology and my coding skills, but that's still quite nice to see. So what I did there was I sent a generic on-off set message. That's the message name. If I send the same message type with a value of 0, they all switch off. That's the simplest possible use case. And again, I'm just using web technologies here with a little bit of extra knowledge to tell me how to formulate these mesh messages that I'm kind of wrapping and then injecting via the one device I'm connected to. We can do other stuff. There's tons of things you can do. I've implemented some level control. So, oh, hang on. It's currently off, that's why you can't see that, so let's switch on. But now only some of the LEDs are lighting because the level is lower. So there you go, so I can change the level to absolute values. I can, not work my computer. I can send delta set messages, which increment or decrement by, let's go backwards, in fact, a specified amount. Does anyone hate the touchpad on their laptop as much as I hate mine? There you go, so we can do stuff like that. Again, these are what we call generic capabilities applicable to any product. These could be the lights in a building, it could be the heating system I'm controlling, it could be anything. We can do dynamic transition as well. It's called a move. If I basically say move by this amount, large amount, in a certain time, there's a time parameter down there as well. What we have there, of course, is a speed. You know, travel through this much change in this time, well, that's speed. So if I hit, oh, that doesn't look right, this button now, this work. One of them's dead, don't know what's happened there. Aircraft travel, didn't like it very much, don't think. But there you go. So the entire point of this demonstration, let's switch them all off so that you're not having this burned into your retinas. Oh, go on, go off. Yeah, one of them's not happy. Rebel, yeah. There we go. Was just to introduce you to the fact there's a thing called Bluetooth Mesh. It is a really amazing new technology that's becoming increasingly popular. So don't forget, it's for you as well. And that's what it looks like behind, by the way. Everyone seems to want to look behind it. Well, what is this? All the wires are because it's powered by a single power source rather than 64 batteries. So that's all the wires are. Right. So I've got no idea how I'm doing for time because I, as usual, forgot to press start. So someone else will have to kick me off stage when the time comes. Who here has actually worked with Bluetooth Low Energy already? Done some web Bluetooth stuff? A small number, okay? So I'm going to tell you some really basic things. I'm not going to make a meal of the theory. I'll show you a bit of code as well, but at the end I'm going to show you where to go to learn more. Like there's a 1-hour tutorial you can download from our website and you'll know everything you need to know to create amazing applications without using tables for layouts. So on a Bluetooth device like this kind of thing, or your activity tracker or whatever, there's actually a table called the attribute table. It contains data that relates to the current state of your device, various aspects of the device, different characteristics, we might say, of that device. It's not a flat list, it's a hierarchy. And it has 3 levels. At the top of our hierarchical data structure, we have things called services. They're like grouping mechanisms, containers. What they contain are things called characteristics, which is a fancy name for data item. Each data item has a type represented by a UUID and a value, and those things represent some aspect of the device. So when I was kind of streaming accelerometer data into my live charting thing, I was actually getting data from a characteristic called accelerometer data. Who thinks of these things? Brilliant name. So that's where that data was coming from. The operating system, if we can call it that, was dropping values that had just been polled from the accelerometer sensor into that value in this table, and I was getting that into my application. So characteristics are kind of where the action's at. You'll be working with them a lot. Descriptors are optional and sometimes are associated with one of these characteristic data item things. They give us extra information about that characteristic. They let us switch certain capabilities on or off, and so on. But mostly the action is around the characteristic, and you'll see this in code. So you saw the kind of general flow that I went through in all my demonstrations, however they went, the flow was the same. We have to do some device discovery first. So we're going to have one device, the small device usually that's doing this broadcasting or advertising thing, saying, hello, I'm here. And there's some data in those packets we can use to filter on. Your application, your web app, is going to use web Bluetooth APIs to do some scanning. That means receiving these packets and filtering based on some criteria, such that we can present to the user a list of devices that seem relevant to your application only. Once the user selects a device from that list, and only then, the two will connect. I stress that last point because it's not possible with the web Bluetooth APIs to kind of quietly, sneakily connect to devices behind the scenes. That would be obviously a very clear security issue, so you can't do that. It requires a user gesture for that to be possible. Once the two are connected, your application, your web application, needs to know about that attribute table. It needs to say, well, hang on, well, what services do you have and what characteristics are inside each of those services and so on. So that's a process called service discovery, and there's one API call you make to initiate that process. And once you've done so, you know everything about that device, and you can decide, well, actually, this is not a device I really want to talk to. It's not got what I need, or great, that's exactly what I was hoping for. And once you've done all that, you then talk to the device. So it's a kind of 3-stage process: discover, select and connect, service discovery, and interact. Yes, that's 4. Okay, I can count. So what can we do once we're connected? Well, again, remembering that table of information, characteristics are really just fancy data items. We can do things like read values, and we can do things like write values, if we're allowed to. So there's like a permissions thing as well, so you can't necessarily read and write every characteristic. You'll find out what's possible by looking at the definition of the device you're working with. But certainly, you can read values. I'm using medical devices here, by the way, because I actually genuinely think that if you were going to launch a national kind of remote healthcare service where people's medical devices were part of a system, so you're actively monitoring patients to make sure that their vital statistics are good so that they don't go to the hospital or the doctor when they don't need to, help kind of de-stress your health service, certainly a very topical issue in the UK, then I think this is how it would be done. It would be done with web technology. How else would you do it? Okay, no other way. So, reading characteristics, absolutely something you can do. Changing them, provided you're permitted to do so, you have APIs for that, and things like driving the car around, if only it had worked. That involves writing to characteristics associated with the motors. And then we have something called notifications, and notifications are where you can say to the remote device, that characteristic there, I'd really like to know whenever that value changes, or just tell me every second. Okay, so you just send one command that registers an interest in that characteristic and its value, and then you start getting proactively, kind of asynchronously delivered values of that characteristic over the connection once you've switched it on until you switch it off. There are other operations, there's maybe 8 specified, but these are the ones you use all the time. Read, write, notify. You can do most things with those 3 operations. There we go. So with that in mind, let's look at some code. How long? 3 minutes. Excellent. So I'm going to go really fast now. Or ignore, pretend I didn't hear that. I don't know, one of the two. I can't decide. So let's look at some code. First thing, so there we have an object where I'm specifying some filtering criteria. So the definition of this object is in the Web Bluetooth spec. Here I'm defining some filtering criteria. I don't want to show the user every single Bluetooth device that's around. Don't want them to see all my neighbor's stuff. It's irrelevant to my application, whatever that should be. So advertising packets often have a device name in them, so that's a great candidate for filtering on. And those Bluetooth service things I mentioned, I'm going to need to also say which of those I'm interested in my filtering object. Then, and this is our first Web Bluetooth API call, it's all promise-based. Navigator.bluetooth.requestDevice, that's what initiates the scanning process. That's what populates that dialog that pops up. I didn't make the dialog, that Web Bluetooth API does that, and it's only when, and the options object there is my filtering criteria, of course, when the user selects one of the devices from the list, the then clause gets executed. We're given an object that represents the selected device as a parameter, and I say, thank you very much. I probably store it in a variable, and then I go and connect to it. The real point here is not the detail, it's just how easy this is, okay? Hopefully anyway. To connect, I've got some Web Bluetooth functions I can call in the object that I've just been given. One of them is connect. Don't worry about GAT there. That's another Bluetooth technical term you will see from time to time in APIs. Once I've done that, I'm probably going to do something like register an event listener for disconnections, because I do want to know if the device disconnects. Maybe the user walks out of range, so I want to take care of that. There's a user experience opportunity there, if nothing else. And again, remembering our flow, now that I've connected, my next job is to do that service discovery thing. So I'm calling a function of my own, discover services and characteristics, which looks a bit like this. This is a summary form. So services, we have several of them on a device, and each of them contains one or more characteristics, and each of them contains one or more descriptors. So we have a nested loop. We've got to iterate through these things. Calling get primary services gives me an array of service objects. Then I can say, for each service, store some stuff, and then let's find out what characteristics this service object has. Nested iteration, bit by bit, I discover all of the services and characteristics on my device. And if there's a characteristic I know I'm going to be working with, like maybe reading or writing to, I'm going to store it to one side in a JavaScript variable, kind of cache it so I can make use of it later on. Here's an example of how I start notifications. Reading and writing is like one function call, very, very easy. Here what I'm doing is taking one of the characteristic objects that I cached when I was doing the discovery process, and the web Bluetooth function I'm calling is start notifications. What I then do is add an event listener, which will register a function that will be called every time a new value for that characteristic is delivered over the connection. We don't know when this is going to happen, but it will happen. We'll start to see values coming in. Our function, our associated function, will get called, and we'll process the data that we're provided with there. And you can see at the bottom there, all I'm doing is basically extracting a uint8 array, which I'm going to do some stuff with. Detail doesn't matter for today. And that, my friends, I trust we are friends. I'm going to bribe you in a moment so that we are friends, okay? I'll come to that in a moment. It's kind of all I wanted to tell you. If you want to know more, though, we've got lots of stuff at our website. See if you can remember this. It's bluetooth.com. Shall I write that down? You're good, okay. I knew you were a smart bunch. So at bluetooth.com, I think you click on Develop with Bluetooth, and it takes you into an area that's all for developers. Lots of kind of hands-on coding, educational resources, including one that's all about kind of general Bluetooth low energy. That's the top one there, Bluetooth Developer Starter Kit. And then we have the web Bluetooth tutorial, which gives you some grounding in the basic theory, but then it's like, let's get on with it, let's do some coding. And you actually make some stuff and exercise the various things I've talked about today. And that is it. Thank you so much for listening.